Let's start to do we have content? Yeah. Oh. Okay. When you want. No, shall we wait for 5 minutes?
Well, still here.
Yeah, let's wait for 3 minutes or so. We start 9 minutes after.
Okay.
5 minutes.
Okay. Hang on, vor die Kinder. Anwesend, abwesend.
This was many years
ago.
In the 90s, when Eberhard always needed the loud voice, Eberhard to collect all people for the meeting and so on. And then somebody bought this bell in a small shop in market, on the street, street market.
Yes, now.
Yeah, since many years, this follows our ESOPs and goes around.
It is tradition.
Historic. Sorry.
Maybe
we can engrave here.
Yeah.
I think that's
So 1 minute, and then we will commence at 9:05 this morning in sunny, warm Granada. So I think we begin. So welcome everyone to the second day of ESOP 41. It is 9:05 in the morning in Granada, Spain. Nice warm day, and we expect the temperature to reach 36 Celsius later today. Wherever you are connecting in to see the meeting, I hope you also have nice weather. This morning's session, we have contributions from our colleagues, observers in Poland. And the first talk is by Julia Perla from her work towards her bachelor's degree at the Borovich Observing Station, the Astronomical Institute in Poznan. So, Julia, good morning. You have 20 minutes for your talk, and then 5 minutes for questions from the group here or from the internet. We will give you an indication with a few minutes to go if you need reminder of countdown. So if you can present your talk, please.
Okay, thank you. Just give me a second. Okay, so good morning, everyone. As it was mentioned, my name is Julia Perła, and I'm a student of astronomy at Adam Mickiewicz University in Poznań in Poland. Yes, and I would like to present you the topic about analysis of stellar occultation by asteroids observed from station in Borowiec. Borowiec is very close to Poznań. Okay, and it was mentioned also that topic was a part of my bachelor thesis, and my supervisor was, and actually still is, Professor Marciniak. Yes, and I would like to show you some results from that thesis. So let's start saying something more about Borowiec Station and the equipment in there. There is photometric telescope with mirror, 40 centimeter mirror. It's Newtonian on parallactic mount, and the camera is under Zilla 5.5 with a CMOS sensor, and I use GPS as the time source. What is the possibilities and the limitation of the telescope? The field of view of the telescope is less than 2 minutes in our angle, and in the declination it's basically 1:45, I think. It's really important because our telescope is a little bit broken. Broken is telescope guidance, because and this is why it's very important, because it's motionless telescope. So I need to calculate the coordinates and put and set the coordinates on the telescope and wait for the occultation. And the broken was also camera focusing, but now it works since summer holidays, so we are very happy about that. And the brightness range of the observed stars was 12 or 13 magnitude, depending on the focusing. But now it's something more like 14 or 15 magnitude. Now I would like to show you some frames from occultation. This is occultation by Pretoria asteroid. This is on the first picture, there is a first frame before occultation, in the middle of the occultation, and the last frame is the first frame after occultation, and that occultation lasts 30 seconds, so we can see how fast the sky is moving. What about data reduction? I use C and Python programs. They are available in our institute. Yes, I mean to take into account bias, dark, and flat frames. And to do some photometry, I use Gaia tool. I can't use Tangra because when I observe in motionless telescope, there is some problem with the shift before. Yes, the apertures can't guide behind objects on the frames. Yeah, the advantage of the Gaia is good tracking of the apertures behind objects. These are some statistics of results from the station. I received 7 positive results and only 3 negative. And I've observed for 1 year. That's the period of time to my thesis. And what more about statistics? Thanks for Euraster, I could compare the results from occultation to results from satellites in infrared. And for one asteroid, there was a possibility to determine the size in 2 axes. For 4 asteroids, to determine only the diameter, and to 2 asteroids, it was possibility to calculate only the minimum size, because my positive observation was the only one. And I marked in red the asteroids for which the results from occultation phenomena may indicate the incorrectness of one of the diameter values proposed in literature. And additionally, future predictions for asteroids Scary and Mickiewicz could be refined, because the phenomena was catched on the body of the path shadow or in 1 sigma path with very low probability, around 20%. So I would like to now present some exact results for the 4 most interesting, in my opinion, asteroids from my thesis. So the first asteroid is Pretoria, and on the left side there is some predictions and designated moment of occultation, and on the right side is light curve. As I mentioned, it was a very long occultation. I think that's the longest I've watched so far. So yes, and it was my first occultation observed by myself. Yes, and there are some chords from occultation. Mine is with number 4 here. Yeah, and the ellipse was fitted to chords. And some occultation analysis, I mean science determination. The size was determined in 2 axes by stellar occultation by Euraster, of course, and so we can compare it to Akari and IRIS satellite, and we can see that the result is from occultation is closer to the results from Akari satellite. The second asteroid is Lorelei. Yes, and as before, there's some predictions and light curve. And that asteroid has shape model. Yes, so this shape model was fitted to chords from occultation. And that was the Polish campaign, because all of 3 positive results are from Polish people. And what about size determination? The size was calculated to 175 kilometers. And such as before, we can see that it's closer to a Akari mission. Third one is Iante. Yes, it was really hard to catch because the sun was only 8 or 9 degrees under below the horizon. So yeah, under the horizon. So it was the sky was really bright, Yes, but I did it, and I'm really happy. I'm really glad about it. There was 2 positive results, and the shape model was fitted to course, and site determination. The size from stellar occultation is consistent with the Akari and TWICE satellite. And the last one, the last asteroid is Mickiewicz. That asteroid is important to our university because Adam Mickiewicz is a famous Polish poet, and he is a patron of our university. Yes, and that phenomenon was low probability, only 20%, but we can see the 3 points in occultation. My positive observation was the only one, so there was only a possibility to determine the minimum size of that body. Mickiewicz has at least 23 kilometers, which is consistent again with Akari and TWICE satellites. Okay, so let's sum up our presentation. The presentation included the results of my own observation of several occultation phenomena. Despite the poor condition of the research equipment, broken focusing and no tracking of the sky movement, there were 7 positive and 3 negative results. 8 observations were included in the EURASTER database, and data collected in the thesis helped to verify and scale 2 asteroid models, Iante and Lorelei, and to determine the size in 2 axes for the asteroid Pretoria. For each of the asteroids, its minimum diameter was determined. Size analysis helped to verify possibility of incorrectly determined diameters for 2 asteroids, and their results contained in the thesis in the future will be used for some research and publication. And yeah, we are very happy because focusing has been fixed in recent months. So now it's in better condition, and we can reach fainter stars. So yeah. Okay, so that's the end. Thank you for your attention. And in this moment, I would like to especially thank my supervisor that she introduced me in the world to stellar occultation and sharing a lot of her knowledge with me. So thank you very much again.
Well, thank you, Julia, for that very interesting presentation. You have finished quickly, but perhaps we will have questions from the audience or online. But one comment I will make was, I'm very impressed. In 1 year, you obtained, was it 7 positive events? When we began this, we hoped for 1 positive per year. And that was a great celebration. It shows how occultation science has moved on. And I'm very pleased that you are new to this field and you have had such success. But one question I have, where you showed the data from EURASTER, the chords and the shape model fit, just for interest, have you looked into occult software to do your own fit to the shape models? That is fun you can have in occult.
Yes, I thought about it, but for this special thesis it was too much. But yeah. In the future, I really would like to learn how to do that thing. So yes, I'm really curious.
Yes, certainly. For your bachelor's degree, that was enough work anyway. But for your own interest, because now you have got, as we say, you have caught the occultation bug. And I hope you continue to observe these. Are there any questions from the floor? Yes, please.
Should I use this? Hi, Julia. I'm Pablo Santos Sanz from the Instituto de Astrofísica de Andalucía. Okay, I suppose that the diameter sizes you are deriving are area equivalent diameters, right? In order to compare with these thermal diameters.
Yes. Correct? The thermal diameters are equivalent, but those are calculated by a raster for that moment of the occultation.
And are you using the information of the rotational light curve of these objects or not? In order to correct, because when you obtain the occultation, this is just a snapshot of the real 3D shape of the object. And if you have the rotational light curve, as we do for TNOs, you can obtain more information. And also, you can obtain the albedo very easy. If you have the absolute magnitude and the size, I don't know if you are thinking in include this in your thesis. I think this is a really important result and easy to derive from your sizes.
Yes, it's really important, and I consider that albedo things. Yes, it's.
Okay. Thank you, Julia. Thanks.
Thank you. Yes, I think this is perhaps enough work for you to a bachelor's level degree, but if you were to perhaps continue this to master's or doctorate, then there are deeper levels of science analysis you can use. And yes, are there any questions online? Any comments?
I have a short question.
Conrad has a comment.
I have just a short question to you and to Anna here in the auditorium. I saw in the charts you have a different observation. Do you run 2 stations in Poznan? Or?
We have 2 observatories, 2 stations in Halin and also in Borowiec, but I observe only from Borowiec station, but Professor Marcinak both of the stations.
So your station is closer to the city?
Yes.
Okay. So it's nice to see you have 2 stations in your group. That's very helpful for the observation tracks. So sometimes you are my neighbor in observations there. That's why I asked. Thank you very much.
Thank you.
So, no more questions? Well, thank you very much. We are so pleased to see a younger person observing occultations. Thank you.
Thank you very much.
And good luck with your studies and your observing.
Thank you.
Thank you. So we now move on to your supervisor at the Institute at the university. We have Anna Marciniak, who has a very special interest in slow rotating asteroids. And she comments that these are somewhat neglected in the occultation studies. So this is a specialist field at the Faculty of Physics, and she has initiated a new observing program, a tag in Occult Watcher cloud, to identify occultations by these slow rotating asteroids. And the scheme is to combine the light curves of the slow rotators with the chords from occultation work. But Anna will explain it much better than I can. Thank you.
Sorry? Yeah. Mhm. Oh, yeah, thank you. Good morning, everybody. So yes, last year I gave you some update on just after the beginning of the slow rotators campaign within the occultation community, and now I will give you another update after another year, and the results are beginning to be really nice, and we are starting to get multi-chord occultations that can now be fitted to our models, and I will just present the results. Arrows. Okay, and now the arrows work, right? Okay, thank you. So yes, for those who haven't heard about my project yet, for now 10 years now, I've been focusing on asteroids that have been neglected not in occultation work, but in light curve studies, because light curve are collected also mainly by amateur observers, and they prefer to focus on asteroids that rotate relatively quickly and have large amplitudes. That's also, sometimes they have no choice because only these objects stand out of the noise and allow to relatively quickly get the full light curve coverage. Also, the professionals focus on them because they have their limitations to public quickly and things like that. There are many reasons for these selection effects. But I was shocked to see how big this bias is, because this is only histogram for, it's not a histogram, it's a pie chart for the first roughly 1,000 of brightest asteroids. Divided by the median period, which is around 12 hours, and median amplitude, which is roughly 0.25 magnitude. So we have here quickly rotating asteroids, well, at least shorter than 12 hours with large amplitudes, and we have other groups, and this is my my group where I focus, because we have very few spin and shape models for slowly rotating and low amplitude asteroids as compared to the others. The situation is even more dramatic if we go to fainter or larger numbered asteroids, because the models that are available are focused only here. We have a few hundred models, spin and shape and 3D asteroid models, basically only for those, while we have just a few here. So now, if other researchers take it as a granted, as a representative of the asteroid population, they get it wrong. Okay, it's not what how the nature looks like. We are strongly biased in our research, and I want to counterbalance what we know about spins and shapes of asteroids. So here is the list that I advertised among occultation community, because I have lots of light curves collected over many years for those asteroids. All of them rotate slowly with low amplitudes. Those highlighted ones are even expected to have Gaia estimate, mass estimate from Gaia mission. And we were working on this list, but now I call it previous list, because now it's updated. I will come back to this at the end. This project. Sorry. Okay. So here's a sub-site on the IOTA-S website with the short description. Okay.
So Nico now can mute everything.
Okay, thank you. So short description of the project is here, and here is the list that I just showed you. But it would be absurd to require observers to go and check if the asteroid is on the list or not when there is a predicted occultation. So now there's a separate tag in the Occult Watcher, also on Occult Watcher Cloud. So it's not always visible in the desktop Occult Watcher, but if we go to Occult Watcher Cloud, to the main site, there's a campaign, Slow Rotators. And then there are predicted events. So the list is never very long, so you can quickly go through it and check whether any event from slow rotators goes over your site. So now this is the summary over just the last year, not the whole campaign. So for predicted events, I count only those that had at least one station announced. Many more predicted, but in some not much populated areas over the months, over the last year. So predicted versus observed, and some highlights. So although there were many events predicted, there were not many observed, not many chords in the beginning, but then came February this year. And for example, for Stereoscopia, we got 4 positives, including 1 grazing event. And for Gunlot, we got 5 positives. I was very happy to see the results, to see them coming. Because, for example, when I presented last year, there were only 2 multi-chord events, where now we have much more. In March, there were 2 amazing Ohio campaigns, both partially in Poland, and it was the first time when I got positive for one of my targets. And then there was April without observations, and some more later. In a summary, there were 30 events observed for slow rotators over the last year, 6 with multiple positive chords compared to the last year when there were 20 events and only 2 with multiple chords. So multiple are at least 3. And for example, Stereoscopia. So now I will present those highlighted. It was actually observed in the US, because now I also search for events all over the world and give a talk whenever one of my slow rotators is predicted to occult a star somewhere. So this is this grace, very nice. And some elliptical feet from Eric in Eurostar. So now I'm presenting only the initial observing results, while later I will show how they fit the models. So this is this Gunlot 5-chord occultations, also very nice with close negative, also very useful. And the first Ohio event from 11th of March. The model in the background is not mine. It comes from Durek et al. Work from a few years back. It was based on sparse data, because asteroid can be shapes can be reproduced either from dense light curves observed over many years, or sparse data from some sky surveys where there are hundreds of points, not creating a light curve because there's 1 or 2 points per night, but still there's information on its rotation and spin axis, but not much information on the shape. So it's no surprise that they sometimes don't fit occultations very well, because, well, there's not enough information on the shape in the data that have been used. But please remember this quality of the fit, we'll come back to it. So this is my only own observation, positive observation for one of my targets. I gave too long exposure time because I was so worried it will be lost in the noise or somewhere, because I expected a 5-second event, but it was only 1 second something from my side. But still, well, by Eric, it was assigned as CERN, but luckily it found its way to raster and later to the databases, because it's an important point. This was very nice event because it was the other Ohio event from 24th of March. One of my colleagues present here, Maciej Borkowski, actually observed both. And this is my grace. It's outside the ellipse, the initial ellipse, but please wait. And this is the example of what we have done over multiple years. Actually, Ohio, when I started to work with it in 2014, the paradigm was that its rotation period is around 19 hours. So nobody touched it since many years because it's long. So when I started the slow rotators, to my surprise, I discovered that huge percentage of the sample, like 20 or 25%, had wrong periods. But those periods were used for many further studies. So it's really important to bias even the periods. So we discovered that the period is actually 37 hours. And observing from one station, because each color is one night run, sometimes it's multiple stations all over the world. It's quite a huge campaign. But all in all, in a few weeks, we are capable to cover full rotation period. Okay, there might be some phase angle effects in between, some shadowing, so amplitudes grow larger, but still we can combine the light curve just for a period, synodic period determination. What we do later is collect such light curve over many years so that we see asteroid from multiple angles, and only then we are able to invert those light curves. That means we are asking the question, how does the asteroid looks like so that it creates such light curves? So the amplitudes didn't change much over the years. That means the spin axis must be roughly perpendicular to its orbit, and it's generally rather symmetric, so we don't expect any weird shape here. So that's my model from the method designed by Mikko Kasalainen from Finland. It's seen from the equatorial here in the two images here, and from the on geometry on the right. This is now the sidereal period. We can go to very good precisions in this. It's some fractions of a second, because we observe over many years. This is the average of a model light curve fit to the data, and it's not visible, but the beta is rather high, and lambda. It's ecliptic coordinates of the spin axis. The uncertainty seems large here, but it's normal, because when the spin inclination is high, then it's not a big distance on the celestial sphere. And this is just, oh, sorry for the resolution here, just an example of how the model, the red line, fits the data, which are blue points, but it is not well visible here. This is just the selection. We collected tens of light curves for this object. Oh, it's so faint here, I'm sorry. Do you see the outline of the model, hopefully? Oh, sorry about this. This is my best result, actually. And it's so badly visible. Anyway, there was one archival observation with two cores from 2017. And these are two events from this year in March. And actually, we were so surprised to see it, because the model created on completely different data on light curves fits so well the occultations. We didn't change the model to fit it better, otherwise than just scaling it and shifting the center. So it's line over points fit. I've never seen such a good fit to any of my models. And this is the other event. It also fits well. Some uncertainties here are larger, but here apparently, you have to believe me, my model is a bit larger in this dimension. It doesn't mean that the occultations are wrong, because they are rather consistent and confirm each other. It's that my model is imperfect, because we are now getting to the level of the resolution, the limit of the resolution of the convex inversion method. We cannot get any better with light curves, actually. And the ultimate aim here is to determine the volume. So volume equivalent size here, because this is what we get from occultations, is 74 plus minus 2 kilometers. And this is also very nice. It's extremely small uncertainty here. Previous studies on these and other slow rotators, some determinations can even differ by 30%. While we here pinpoint the model, because, well, models, the sizes based on thermal data, I assume that asteroid is spherical and has some unknown spin axis, so some is assumed. And this is not really the case. Many asteroids are elongated, weird shapes, and thermal observation just catches snapshots on some random rotation phases. So this is why some infrared size determination differs so much from each other for the same asteroid. While now, when we have full spin and shape, detailed spin and shape model, we are pretty sure that it's this big. Okay, another object. Oh, sorry about this. It was very nice. You can see later. I will upload the presentation. In the Zoom, it's okay. Yeah, only here it's too bright, also too thin lines, and now it's visible. But very rich set of events, mostly archival, and also pretty well fits our model. You have to believe me now. You can check later. Another great power of occultations is resolving the ambiguity in spin axis, because from light curve inversion we usually get two symmetric solutions, same spin axis latitude, but two different longitudes, usually differing by 180 degrees. Such models would create exactly the same light curves, but not the sky plane images of asteroids. But this we don't know from light curves. We have two equivalently good solutions, while the occultations usually, often allow to break this symmetry. For example, this is the case. You can check later. And again, it's quite big asteroid, which we nicely scale it. Oh, this is better, because I also do first tries with ADAM method. ADAM means all data asteroid modeling. So this is the method, a different one from it's a light curve inversion, but amended with any kinds of data that you have. For example, occultations, radar data, resolved adaptive optics images. So here we allow both the light curves and the occultation to influence the model. So we feed the method with both kinds of data from the beginning. That's a different approach. We don't do a posteriori feed, just a priori feeding the data. Many events from the past, and fit is pretty nice, except for this. Yeah, I actually use ADAM to trying to fit this, because ADAM allows non-convexities. That means some dips, some large craters to be present on the shapes. Still, it cannot reproduce. Whatever I do with it, it cannot reproduce this chord. Maybe the duration is okay, but it's just should be shifted. And maybe if my model shrinks a bit, it would fit, but then it would misfit the others, because it's a simultaneous fit to all the occultation data. However, here it fits better than the convex model. Now to Randot, maybe a bit better visible. The rejected spin and shape solution and the adapted one fits much better to this event. And like this one, also here and here. But to Randot, I also tried with ADAM, because whatever I did, I couldn't fit this lowermost chord. We could also think that it's wrong, maybe wrong timing, wrong absolute timing. However, my best model actually managed to fit it. So sometimes it's not the data that are wrong. Sometimes it's just our model that is imperfect. And now it fits really nicely. And some non-convexities are visible, but I'm not sure if these are not artifacts, because they are not where the chords are, or maybe here. One would have to check the aspects. Another one, Fidelio, all for the accepted solution, but not very well visible. There was one lost event from not available in the occult. So we had to contact the American observers to actually upload it, because it was in their website, but not in occult. So it was actually the event that allowed us to choose the preferred solution. Another one, Stereoscopia, nicely covered last year event, and the one with the grays this year fits nicely. You can see later. And the observers of the recent events, are those since that I announced the campaign, but of course, since we are using also the archival data, all the names will be mentioned in our upcoming paper. Of course, I want to thank everyone who's here and whoever tries to observe slow rotators. Please continue. You are doing a great job, and you can see how your data are needed. So the list is evolving now, because we modeled and scaled asteroids. So those in gray now go out of the list. Case is closed, at least for now. We did the best that we can do with them, with the currently available data. But we amended the the list with the new ones, some with very interesting topographic features, like shown yesterday. Apparently some two hills on asteroids, like on Thuringia. It's not here because it's not long period, but I'm also interested in this one. So those in red are new ones. So now we will update the list on the IOTA-S website, and now the occult water tags will be for this list. So most of the list is the same as it was, but we have some changes and some additions. Okay, yeah, I'm close to the end. This is my summary. So the slow rotators campaign, to my delight, is spreading. We are getting more and more multi-code events. So please keep joining the campaigns. Please keep observing. You can just upload, report the data as usual. There's no need to send me the frames or the data unless we have some troubles with the fitting. But then I will contact the observers. So please watch for the slow rotators tag. We had 30 events with 6 multiple positive chords. And recently we scaled in this way that I just showed 15 slow rotators. The paper is in preparation. It will be sent to Astronomy and Astrophysics. So one of the most successful campaigns is Ohio with 2 events. And slow rotators were scaled here with accuracy even from 1 to 5%, while the sizes were divergent previously by 30%. Thank you very much.
Thank you, Anna, for keeping to time and great detail. I'm guessing that, as we say, the streaming is clear out of your presentation and on your screen. I think sometimes it is the different color scheme of the video projector, which a different resolution, which but very professional to maintain your presentation on all slides. I'm very pleased that you have got now getting positives and multiple chords with your slow rotators project, and you'll be in touch with the Damit shape model team. But do you have contact with the Gaia GOSA project, which does select light curves? Yes, I know.
Observing there, sometimes we share observers between the 2 projects.
Yeah, yes, because they highlight asteroids of interest. Please observe these light curves. So yes, you can push the slow rotators on Gaia GOSA.
And overgrew the expectations, and we have even more data than we need.
Yes.
In our occultation.
Okay. Any questions, please?
I have a question about ADAM. Is ADAM as a separate solution or some kind of successor of ISAM, which was created by your institute as well?
ISAM is a database, while ADAM is a method to create models. I mean, maybe you meant dummy or no, you meant ISAM. Well, ISAM is basically the mirror of Damit database.
Yes.
There are the same models here and there with some updates and copying. While ADAM is a successor of a light curve inversion method, the classical convex inversion method. So whenever the data justify expecting some weird shape features, some non-convex shape features, we can use ADAM. Otherwise, we use convex inversion. It's quicker and it's easier.
And can the ADAM be implemented? So how, for example, in occult water? Sorry, occult, but
no, I have no idea. The models, for sure, even now, the models in Damit, some of them were created by ADAM already. But this, I don't know. It's complex. You need quite a lot of experience to create models with ADAM, not to let it go to weird directions with weird shape features, not justified by the data. So it's quite steep learning curve, even for me with Adam. But you can try it. The code is available.
Thank you.
So I have a similar question. So the Adam results are available on a database in your institute, but they don't influence the DAMIT database.
They do. Well, no, it's the other way around. It's the DAMIT database that influences ESOP. With the exception of some models from the Horizon 2020 project that were put only into ISOM, but these are just a few targets. Basically, the two databases are equivalent.
And in Adam, you have a scale of the asteroid.
Yeah,
I have a problem with our method here developed by Frank of the spatial presentation of the occultation data. And for Ohio, there is no scale available in DAMIT. And I think we have enough information now to have a scale.
Of course.
So
that's why we do it.
I need a better DAMIT model, and I'm just waiting. But now I can ask you for the Adam model as base for our work.
Yes.
Great.
Before it gets published, it's only available for me privately. But just as the paper is accepted, it will be uploaded to DAMIT. But if you need it earlier, then sure, please contact me.
Okay, so we can try to proceed our method to your data in for Ohio.
Yes.
Okay, let's do it.
Sure. More questions?
Please, one quick one. Can you put it in the Ohio recipe like that? I'm curious about the side. Okay.
Yeah.
What is relative C and R magnitude?
What
is this?
It's basically observe unfiltered because we need as much signal as possible.
Yeah, okay,
or in R filter in some observatories, these are equivalent.
But you merge what
yeah, we need to shift, so it's only relative. We don't observe absolute.
Okay. Yes, I was thinking about what the C filter.
Just clear filter, no, or unfiltered.
Okay. Thank you.
Yes.
And Anna, do you plan to compare the your diameters in equivalent volumes with IRAS?
Yes, that's what we are going to do. Although our diameters are volume equivalent, while those from thermal are surface equivalent.
Yeah,
right? They are almost
straightforward.
almost the same. Yeah, but we are going to compare those.
Yes, but also in this case, if you use the thermal, you have to know very well the rotation phase at the moment of the thermal observation.
Yeah, but usually it's unknown. Before it was unknown, it was assumed that Ohio is a sphere with unknown periods.
But now we can do it.
Yeah, now we can do it.
Yes, but you need to go back to the time of doing thermal observation.
Okay, yeah.
You need a very precise rotational period.
Yeah, but they have.
Yes.
Any comments online? Questions?
William Stewart, is there a way for Occult Watcher to highlight asteroids that are high priority for other campaigns such as Small Rotator?
Yeah,
there was a list of numbers, names on one of the slides.
Yes, there is a separate Occult Watcher tag now. Although, even for me, in the desktop version, it's not always visible. I don't know why. But if you go to Occult Watcher Cloud, it's there. Whenever there is an event, I add my tag. So if you see the event in the Occult Watcher Cloud and it has a tag slow rotators, then surely it's one of mine. It's high priority.
Yes, I think in Occult Watcher Cloud, there's many tags. And this includes slow rotators. I might be wrong, but I think perhaps back to Occult Watcher, it comes up as community feed.
Yes.
Perhaps you can always know it is slow rotatable, but it does appear.
Yeah.
But yes, we can look at that and highlight for observers.
Yeah.
So, if we have concluded, yeah, thank you very much, because I know we have a Next session coming up with our friend in Algeria connected to us. Thank you. Here's my code. Yeah, yeah.
So, Baba Sisa, are you ready
Yes.
for the next one?
Hi,
want-
hi all.
Yeah,
So
just wait
share
that. Yeah.
my
Can you share?
talk. Yes.
Okay.
Is it visible?
Yes.
So I will start.
Just wait that the chairman will make the introduction.
Okay. So hi, I am Baba Issa Junay from Algiers
Hey,
Battery.
Junai, yes, I am
Yes.
Carlos Schnabel, the chairman for your session and the following one.
This is my 6th participation in the European Symposium Occultation projects.
Okay.
The first
Let's
in
go.
Prague was in 2014. And I will talk about observation of relevant future stellar occultation by near-Earth asteroids in Algeria. So first, I will introduce some information about Algiers Observatory. Then I talk about presentation, what we do. And I talk too about the Algerian observation campaign of the stellar occultation by Didymos in 25 August 25. I will talk about positive stellar occultation by the Trojan Hector. And I talk also about positive stellar occultation by Diotima on February 26 by the Algerian Participative Astronomy Network. And I finish about near future prospects and summary. So this is Algiers Observatory, or Center of Research in Astronomy, Astrophysics, and Geophysics. We have some instruments, 2 Celestron 8, 2 Celestron 11 with the CGM mount, and 1 Celestron 11 with CGE Pro mount, and 1 MID with the diameter of 30 centimeters. We have also 1 telescope of 20 centimeters and 3 WATEC camera with Iota VTI inserters. There is a Didymos team, the acronym of Dynamics of Small Solar System Bodies, Meteoritic Observation and Stellar Occultation. I am the head of the team, and there's 3 members. This is the name of my colleagues, Bouyahiaoui Zindin and Boudiba Ghulam Imaduddin. He's a PhD in progress. He works about Trojan asteroids. So this is the field of research. We work about observation and characterization of small bodies by stellar occultation, observation and characterization of near-Earth asteroids by stellar occultation, dynamics of small solar system bodies, and especially Jupiter, Trojan asteroids, and calculation orbital elements by observation, observation of fireballs and tracking meteorids using a network of all-sky cameras, atmospheric entrance of meteoroids and space objects tracking using infrasound devices, and in projects photometric study of asteroids. You know that near-Earth asteroids are small celestial bodies that revolve around the sun and may collide with the Earth. Therefore, there are considerable interests and stakes in studying and observing them closely. There are several methods to characterize them, such as the radar method, the photometric method, the occultation method, and or even sending space probes to study them in situ, as was the asteroid Eros, Ryugu, or Bennu. In our case, we will focus on the occultation method, but there is a great difficulty to observe stellar occultation near Earth objects because of a very difficult prevention, very low probability, extremely short duration time, etc. So far, only 5 near Earth asteroids have been characterized by this method, as Eros in 1976, Ganymede in 1985, Phaethon in 2019, Apophis in 2021, and recently 1994 AW1 in 2022. Since 2019, we have conducted 8 campaigns mission to observe stellar occultation by near-Earth asteroid, and we generate predictions of stellar occultation by near-Earth asteroids, potentially hazardous asteroids, using occult software. This is the 8th observation. We had only 2 positive observations of Phaethon in 2019. Sometimes there is technical problems. Sometimes we had 1 negative observation to observe Florence. Sometimes mists and dust clouds. Observation campaign of the stellar occultation by Didymos on August 25. So an international campaign of which we're a part was launched by the Across team to observe the stellar occultation by the near-Earth asteroid Didymos. The magnitude of the star was 13, duration is 0.21, and the probability is around 40%. There were more than 4 observers from Portugal, Spain, and Algeria. We moved to 3 points which are more than 200 kilometers away from Bashar, a city that is 1,000 kilometers southwest of Algiers. The Across team has set up 40 lines to observe the occultation. Since we only have 3 telescopes, we have been assigned the line A2, A3, and A4. There are approximately 400 meters between the line. There was a very good organization and the sky was perfect. We all observed the star, but unfortunately, there was a storm a half hour before the observation. Here, the 3 exact GPS points from the A2, A3, and A4 obtained by our instruments. The entire Algerian team, a few hours before the observation, we moved with 2 4x4 cars. These pictures, so this picture of the first team of the point A2, Boudiba Ghulam and Dahmani Della Mohammed. The second team, point 3, Baba Isa Junay, me, and Bouhiawi Zindin. And the team number 3, point 4, Grig Hassan Zaki and Bul Qabul Abdul Qadir. This is the pics. Generate predictions of stellar occultation by near-Earth asteroid using the occult software. So this is the list of stellar occultation by near-Earth asteroids from September 15, 2022 to the end of December 2022. Some of chosen criteria from occult software using ASTROP calculation and the GPL calculation. The star limit magnitude is 12. The magnitude drop equal or more than 0.2 seconds. and the asteroid smaller than 1 kilometer, and the probability more than 10%. We have selected 4 near-Earth asteroids PHA candidates as 9094 AW1, Geographos, 9098 SS49, and Phaeton. The produced occultation using GPL and ASTROB calculation. So this is the first on October 12th. The second Geographos on 18th in Bishar, Geographos, and the third in the 4th of November. And the last one is Phaeton in November 17. And we hope that we are going to observe this occultation. Positive stellar occultation by Trojan Hector in Ores Observatory on August 20th, 2022. There is an astronomical observatory being set up in the Ores Mountains east of Algiers. The project team is measuring the seeing. While my colleagues Boudiba and Dahmani Della measuring the seeing, they took the opportunity to observe the stellar occultation by the Trojan asteroid Hector on August 20, 2022. I will note that Boudiba focuses in his PhD on the dynamics and observational study of Jupiter's Trojan asteroids. This observation is part of the Lucky Star project. This is a picture of Boudiba Ghulam and Imad Din and Dahmani Della Muhammad at the Ores Observatory. And this is the illustration of Hector, the path of the occultation passed by Algeria. The aim was to observe the sudden and a brief disappearance of Scamandria's satellite. This is the Ores Astronomical Observatory, and here the exact GPS point obtained. Now I will talk about participative astronomy in Algeria according to observed stellar occultation by asteroids in 2022. I organized the 11th national meeting to observe stellar occultation by Diotima, Saturday, February 26, 2022. This is the illustration of the occultation of Diotima. Magnitude of the star is 7.4. Duration is around 15 seconds. Very interesting. The participation is about 40 amateurs, astronomers for a dozen association using more than 20 telescopes. And this is the distribution of the amateur astronomers on 12 points along the occultation path. The red dots, it means that this is the place of our colleagues from Algiers Observatory. The green dots, the amateurs with motorized telescopes, and black dots, amateur of using simple telescopes. And this is, we had 6 positive observation. I think that it's a good job for amateurs in Algeria. Next time, we will organize the 12th national meeting to observe stellar occultation by 9/17 Lika, Thursday, December 8th in 2022. This is the illustration of the occultation, and we can find that the star had a magnitude of 5.2. It's very interesting, and the duration is 3.3 seconds. We expect more than 150 amateurs astronomers to participate with over than 60 telescopes. We will divide in maybe 15 points or more than 15. Why not? And we'll organize this meeting in Larwat. It's a town in the south of Algiers, in the Sahara. So summary, we are interested to study more stellar occultation by asteroids, and especially near-Earth asteroids, Trojan, Centaurs, and trans-Neptunian objects. Now at Algiers Observatory, there are a team of 4 members plus 3 that work in this area. We intend uncertainly to expand the scope of work by using all-sky cameras to observe bolides and search for possible meteorites fall. In parallel, we developed the Algerian Occultation Amateur Astronomers Network to observe, firstly, more easy stellar occultation by asteroids, which follows the works of participative astronomy in Algeria. Finally, we wish to create a relationship with other partners around the world, and especially from IOTA, in order to develop this research in Algeria. Thank you for attention. And if there is some question, I am.
Thank you very much, Baba. Do you hear me?
Thank you.
Do you hear me? Baba?
Yes, yes.
Yeah, Junai?
Yes,
Okay.
I'm here.
Okay, I am Carlos Schnabel, your chairman. So, very interesting, and I am
Thank you.
very glad to see that you are achieving great results with a lot of occultation enthusiasts in Algeria, in Algiers.
Yes.
I really congratulate you for this.
Thank you very much. You know, I'm unlucky because I haven't the visa to come to participate in Grenada. Maybe next year.
Yes, maybe next year. Yes, but your participation through Zoom, it's very well welcome. Very warm.
Thank you. Thank you very much.
I think so. I will ask if there is some question here in the auditorium in the hall, or through Zoom, maybe.
Why not?
A question for Junai. But your presentation is very impressive. No
Thank
questions.
You. Thank you very much.
No questions. Zoom?
No questions?
Tampoco? No. Oh, no questions. Okay. Also from Zoom. So many thanks, Junai.
Thank you very much.
And see you next time.
Yes.
In person. Yeah.
Okay.
Many best regards to all the enthusiasts in Algiers.
Thank you.
So goodbye. See you next time, next year.
Okay.
Goodbye. So, and now it's a turn for Konrad Kuhl, president. And he's talking us about the plans for the total solar eclipse in 2023 in Australia. I guess you are planning the Bailey Beds observation. Good. And so yes, it's your turn. So thanks, dear Konrad.
Okay, thank you. Yeah, thank you, Carlos. Carles, yeah, thank you. Yes, I don't need so much time, and this is a snapshot only. The status at the moment, or no, that's not correct. The status from the day before yesterday, and yesterday evening, I've heard in the social dinner that our friend Roman Kostenko always hired an RV to observe, to be present in the eclipse zone of this event. And so we have a partner. So yeah, so it's a snapshot only. So as you know, the observing of solar eclipses with the method of Bailey beads to calculate the solar diameter is a long-term project from IOTA and IOTA ES. You can find on our web page, IOTA ES, a summary of the expeditions in the past, the countries where we visited, you see it here in the 2 letter codes, the observers, and the paper resulted from this observation. So if you need any information about the eclipses in the past, the results, and so on, you can see this in this paper. Most of the expeditions are well described, not all, some in the Bailey Beads Atlas and some in your articles. We have only one gap here as a result of 2016 from David, but maybe we get it in the future. So this is an ongoing project, and more or less after the first spacecrafts are present and we see the method of Bailey beads come to a special limit and the spacecraft will go over this limit, we lose a little bit the interest of this method. But some months ago in the Journal for Occultation Astronomy, some friends publish an article to measure the Bailey beads with a flash spectrum during a solar eclipse. And I must say this was more or less a dream of myself for the solar eclipse 2019 in Chile, and I couldn't realize this due to some technical problems. And now I was very happy to read this article and I was in contact to publish this article with the friends here. And I promise to them, if you are ready with your method for the next total solar eclipse, I will come and make the parallel observation with the old technology of the Bailey beads in the white light to calibrate this with the older observations. And so the friends in Australia agree and said, okay, we will try our best. So the original plan was to have this equipment ready for the eclipse 2024 in Mexico and the US. But now I made a little bit pressure. If you are ready with your equipment, I will come with my equipment. And I did this a little bit in advance before I looked to the map. Where is this total eclipse? And you see, it is a very, very small zone of Australia in the middle of nowhere. In this range, you have a lot of nature and nature. And a big airbase for the Australian Army and a more or less secret solar observatory run by the authorities from Australia and the United States to find solar terrestrial effects, but they're very closed. So
in this range, we want to observe on the edges, on the northern, and maybe if we have another team on the southern edge, you can fly once a day from Perth in this area, or you can drive by car here for, how long is it? 1,200 kilometers. Okay, nice. So I was happy to catch some tickets from Perth in this area. At the moment, it's not possible to find a hotel there. There is a hotel available, but they charge you 1,000 Australian dollar per night for this eclipse week, and you have to book 6 days at least. So I will run again this equipment oft described in your articles and in lectures here in ESOP, and maybe I will lay in the ground here to be shadowed by such a calf to have the darkness to find the focus. You know these problems to observe, and our friends with the new equipment will stand parallel. And so we hope to find a difference, and we hope to calibrate the new method. One thing is clear, the flash spectra will be emitted from a little bit distant areas of the solar surface than the belly beads. It would be really interesting to find out this, and to maybe we can talk about this on the next ESOP. So that's the plan at the moment. The plan is, yeah, on the way to realize. Roman is also present in this area, maybe can help or assist or take some additional pictures. And I'm in contact with the Australian friends and with the American friends, but so far at the moment they don't have any perfect or valid plans for this eclipse. It's a little bit not so easy to reach zone of the Earth. So far, a report will follow on ESOP 23. Thank you.
Thank you very much,
Conrad.
Conrad.
I saved the coffee break.
Oh yeah, but maybe there are a lot of questions. Is there some question? It's very interesting, and I wish you all the look. You were lucky. You were lucky.
So we hope for a nice trip to Australia, nice holidays, and additional observations.
Okay. Yes.
That's agreement with my wife. Yeah.
Okay. But one question is, do you have seen some trends in the observations of solar beads, of Bailey beads in the years, or someone has made a study in some trends?
Yeah, we see a trend. We see a trend, but it is in the band of tolerances. So I would say it's a little bit shrinking, the diameter.
Yeah. But
we need more
yes.
Observation. We need other observations. And as I said yesterday, I very often use these words from Shapley. Theories comes and goes. Good observations stand forever. Observe. That is what we have to do. Observe, save data, yeah, and publish data.
Yeah. Anyway, you recommend to observe Bailey beads. Yeah. Yeah. Okay. So some question in the Zoom? No? Okay. We have plenty of time. So then we will have now coffee break until 11 hours. Yeah. So let's go to the coffee break. Thank you. And Have a nice day.
Yeah. Super good. So no problem. That's why they have okay, no problem. I'm talking with you providing the bank account. Yeah. Also this. Yeah. Also I have this. And one. Okay. Monday. Yes. Tomorrow. Yeah. I need to listen. Yes. You made the decision. No, the listen to you. I can bring. No, I can. I can check to the. Days before. You have to. Then what was it all about? So I was just looking online and so we didn't have this. Now it's going. Yes. So yeah.
Quítale el sonido. Chao.
software, hardware, and procedures. And this is still very important to get the instrumentation rightly done. As many of you may know, we have a telescope, a mobile telescope is 50 centimeter diameter, special equipped with cameras on for occultation work. It's still at the moment, I think it's at the IAA here somewhere. And I think you want to give now a talk about news about the JOTA-AS M2 expedition telescope. You have 20 minutes and 5 minutes for discussion.
So it's more than enough. I save a little bit of time here. I save a little bit of time, so it's more than enough time. It's enough time, yeah. Maybe some of you remember the presentation last year in Bialystok. We had our M2 physically there, and it starts with a big box. And Martina was a volunteer who follows the handbook and to assemble the telescope. You can see this as a video on the webpage from JOTA-AS if you are interested. And one of the big question from all people were, what about this big box? That's not to handle. And so we have some news. Okay. The telescope M2 has a name from the two father of this instrument. Both have the name Michael Dorman and Michael Busse. They designed and produced this instrument. And the first use was for the Pluto occultation some years ago. This was the first scientific use. Later, the telescope was moved to Namibia. Mike Cradlow made successful some observation with this instrument. And in 2020, we got it back from Namibia. It was a little bit in the Corona breaks that the telescope was stored in Namibia, and we the original plan was another observer go to Namibia, make some observation, and organize transport back to Germany. And this was not possible, so we hired a forwarder to pick up the telescope and to bring it to Airport Hamburg. And I picked up this in Hamburg, and it's stored in Berlin at the moment in the Archenhold Observatory, where I'm a friend of the house. And the big box has a big advantage to send it over the world, but it's not usable when you go by car alone in an expedition in the field. So let's have a look to the instrument. So it starts now. Yeah, the last use after the ESOP in 2021 in Bialystok was the Polymele campaign. I was selected to occupy the line number 3 close to Sygienza, and here you see the telescope in the field. It works perfect, but the occultation was not there. Yeah. Oh, sorry, yeah. The following, yeah. Here you see the telescope in the field. My car, the view of the city of Sygienza on the horizon. Nice place to stay, nice place to make holiday. But I had only some hours in the field. And then back in the base where Jose Luis was successful observing this. And okay, that's our job. That's why we do it. So here you see again, M2, the 50 centimeter mirror. Here's the camera. The focus goes with a small electric drive. You have a counterweights. All this is to assemble, I would say, roughly in half an hour, and to calibrate in 1 hour. So it would be good to be in the position 2 hours before an observation. It depends how trained you are with this instrument. Here is another observation. This was Mike Kretlow for Didymos this year, some weeks ago. You see, oh yeah, this is not the trunk, it's a car open to have the electricity. All what you need is 12 volt. And here you see the nightmare, this big box. Yeah, here this man, Mike, is a little bit surprised about this big box and this car. He has to move it in. It weighs, it has a weight of approximately 100 kilogram. All stuff is inside. And here it's a limit, this car. Yeah. Our friend Eberhard has a neighbor, and this company produce special boxes for spare parts for machines for farmers. And they send it around the world, and the spare parts are very expensive. And so they have to pack them very well and very good protected. And Eberhard, as a good organizer, was so clever to ask his neighbor, can you produce some boxes for us, but we don't have any money. And this company said, okay, we will do it. And all what we need is a little bit advertising. And so we made a movie about occultation observation and transportation of telescopes. And this movie is present on the webpage from this company. This was our part, and they made these 3 boxes. Fuchs and Schwalbe is the name of this company, so I must name them here. Fuchs and Schwalbe, and we have the box number 3, 1, and 2 here from top to bottom. And what is inside? The biggest box and the most heavy box is with the mirror and the mirror house. The outline is 70 centimeter in square, and the height is 37 centimeter. The weight is approximately 30 kilograms. It's the most heavy part, but we cannot reduce this. This is only one part of the telescope inside. All this here is one part. You see the mirror is covered, and in the box 2, we have 2 levels, and inside are the both forks of the telescopes. And you see, this is very nice shaped from in wood, so it cannot move. Here you can see this. This is shaped with the parts. So we put really the telescope in this workshop from the company Fuchs and Schwalbe, and they took all the dimensions. And in the second level, you have the base of the telescope here and the finder telescope. All parts are really good fixed, so you can put these boxes in your car and drive in the world, drive in the field. In this very light box number 3, you have the longest one, over 1 meter, are the tube parts. And here are some finger holes. They become free when you move one of this rope. And in the second level, you have enough space for small parts, for oculars, cameras, and so on. What is the plan with these 3 small boxes? They are in plan when an observer pick up the telescope and go in the field. When we send the telescope without an observer by an aircraft, by a lorry to another part, we will use a heavy box, the big one. Maybe that's the that's a project, but maybe it's not the best idea. That's to discuss. Maybe we bundle all 3 boxes with a band and put them on a pallet and skip away the big box. But it's not so good when you see the world of the forwarder. These are lazy and lousy guys, and this is this is an industry where the prices are pressed down, and the education of the people is not so good. So it's not the best world to handle with care such equipments. And in our big box, it's good stored. We know this. It goes with planes around the world without any damages. And with the 3 boxes here in your car, you can transport this. Yeah, these are the news. M2 is at the moment here in the EAA. It will stay here till the next observation campaign from Mark Bouis' group. And then it will be, will go back to Germany, hopefully. And an idea is to observe the event next year, Betelgeuse, with 2 small planets to have an annular occultation or something like that. If you have any plans as member of IOTA ES, it's not a problem. It's your telescope. You can use it on any place of the world. To be a member of IOTA, now I must make a little bit advertising, sorry for this. As a member of IOTA ES, here you have the application form. And yeah, we get 1 new member here on this conference. We are happy and it's fine. 3 we have, yeah? Ah, okay, you're working on. Okay, our treasurer is working on, yeah. Okay, that's the situation at the moment. If anybody has a good idea what's to do with M2, ask us and we plan it and we ship it and we will find a solution. This is the telescope for the community. Oh, these are backup slides here, how it starts. Okay. Maybe not all people know. This was an old presentation from the last year, how it starts. So how it starts, IOTA ES bought this telescope. This was a Dobson telescope. And it was very heavy. And so I tried to go to South Italy in 2013 for an occultation of Uranus, of a star by Uranus. And you see, it fills my car. And it was no balance. Here I put a lot of iron stuff on the back with tape to have the balance of this instrument. This was never, we bought this instrument as used telescope and it was never tested. I say it was never used in the sky. So yeah, a Zenith telescope, yeah. So the first 8 for Uranus observations was a new tube. And this was really here in my living room. This was the first 8 and it was possible to observe with, but then we had the bad weather and I turned in North Italy back to Germany and this telescope was not in use, but we was not happy with the balance. What's to do? We created a new house for the mirror, much lightweight. And then we found out the head is too heavy for 2.5 kilograms. We calculate new. And the other M, this was the work from Michael Busse, and the other M, Michael Dorman, took over this and made the telescope really ready for use. And the nice situation was he had a deadline. He must be ready for the Pluto occultation. And so this is on the floor in the Archinvold Observatory. The first light was on June 6th. Together with Michael, here you see this other M, no, not here. Here you see the other M, Michael. Here he's on the machine, and he is together with the telescope. And you see the tube is not the three black tubes, but then we made a small changing to the new design. And on June 23, we were ready. And on July 17, we go to the Plose mountain in not South Austria, North Italy. And we got this light curve from the, we got this light curve from the Pluto observation. And then we had some changings on the instrument, and this was the official celebration, the inauguration party to give the telescope the name M2. Here you see our former president. Oh, back. How to go back? No. These arrows here? Here, yeah, here you see our former president, Hans-Joachim Bode, Michael Dormann, Michael Busse, a glass champagne, and the telescope got his name. This was a Chariclo event, the result. So the telescope in Namibia reported. This was published in the journal, I assume. And the data are still available. So Mike is the owner of this data here. And after air freight, Hamburg, Namibia again. Kwawa event was observed with this telescope in 2019. Then the Corona break came, and now we made a little bit work on the handbook. The handbook is available in German and in English. And as I said in the introduction, with volunteer Martina, who didn't nothing about this telescope. This was really a nice experiment to say, here's a box, here's a handbook, please assemble this telescope. You can see this as video on our webpage. It works. Don't afraid about this telescope that is too complicated. You can use it if you want, you can get an introduction. So with the backup slides, now I fill the time, yeah? Okay, thank you.
A little, yeah. Everybody has seen now a little from the history also. It's M2 from the purchased telescope where we didn't know how the people observed with it up to the M2 in 3 boxes now.
Now M2 in 3 boxes to transportation by car with 1 man or 1 woman. So it's easier than the big box.
Yeah, but for a long time air freight, the big box may be better and perhaps cheaper, I don't know.
Yes, the forwarder are happy when they can put some other stuff on the boxes, and this has a flat surface, a big box. So maybe you get a better tariff when you have this instead of a bundle of 3 smaller boxes.
So are there questions? Good. Are there any questions on the internet? Okay, thank you, Konrad. This was now we get a report via Zoom from Andreas Schweitzer from Switzerland about the DVTI camera project, status update and Kickstarter campaign kickoff. 30 minutes. So.
Yes, hello everybody.
Hello.
Hello.
I'll try to share my screen now. I hope it works.
No, wait a second.
Can you see my screen with the presentation now?
No.
Yes.
But not here.
Not here. Wait a second.
In the background, it looks like.
Yeah. I cannot see the mouse.
There you see, M2 is very stable.
It's no real mouse. The presentation is
Step by step.
Okay, now it's working. Okay, as some of you may know, we are developing a video camera with integrated time insertion here in Switzerland. Very similar to the Chinese QHY 174 with the integrated GPS module. We have presented the technical details last year at ESOP 40. You can still find the presentation slides on the webpage there. So if you're interested in the technical details and how the project evolved, you can open this old presentation and have a look at it. Today I want to talk more about the now finished product and how we plan to go on and make the camera available to you, to those who want to buy it. This is the agenda. First, I'll present the final product, then discuss the start of the order process, and the last point is some information about the further development of the camera. Just a short recapitulation of what the DVT-I cam is. It is an affordable, easy-to-use digital video camera for observing stellar occultations. And we have also created a software to use with the camera, which integrates with all the tools like Occult Watcher, C2A, and so on, and which can control the telescope, run plate solving, generate the report, the text file, and fill it with all the data from Occult Watcher, and so that you have less possibility for errors to happen when you create the report manually. There is no time inserter, no digitizer, no power supply, just the camera, the cable to the computer, and the GPS antenna. There is also no calibration required. The start and end of the exposure time are calculated from status and control signals of the image processor. The camera is user upgradable. That includes the hardware. You can change the image sensor board at home. And of course, also the firmware. You can simply install a new firmware of the camera when we have new features with the tool. And we plan to provide sensor upgrade kits. So the camera is like a platform where you can replace parts and upgrade it in the future. In the past month, we have also implemented in the firmware of the camera an automatic detection of the sensor. So now you can use one firmware and swap the image sensor board, and it will automatically detect which sensor board is in the camera. This works with a handful of sensors today. And if there are new sensors, we can also add them in the firmware. The development team is Stefan Meister and me. Stefan is in holidays in Italy, so he can't join this ESOP. We are members of the of SOTAS, the Stellar Occultation Association in Switzerland. And of course, there have been many people, many of them also here in the Zoom chat or in Granada, who have helped to develop this camera as beta testers or have given valuable feedback. Here is again the link to the technical slides from last year. So how does the final product look like? We have a small compact housing with a 2-inch outer diameter. That means that if you have a 2-inch focuser, you can directly insert the camera in your focuser. The camera has an image sensor, of course, in the front. At the moment, we plan to sell the camera with 2 different image sensors. The IMX 174, this is the same one as in the Chinese camera, and also the IMX 430. This is a 2 generations newer sensor, also from Sony. Then there are inner threads, an M42 thread to put adapters or filters. There's a 2-inch filter thread if you want to experiment, for example, in the twilight or have, for example, special filters that you want to use, you can insert it. That's how it looks like with an adapter for 1.25 inch or a 2-inch filter. That's possible combinations. Of course, we can't do both at the same time. That doesn't work. The backside has a couple of connectors and LEDs. The most important one is the USB-C connector. This is also the power supply of the camera. It gets the power from the USB port of the computer. So it is for data and for power. Then there is the antenna connector for active GPS or active GNSS antenna. The GPS module we use supports GPS, but also GLONASS, Beidou, and Galileo. So if you use a broadband antenna, you can receive signals from more than one constellation. There are also 2 LEDs. One is a 1 PPS LED, which indicates that the time from the satellites is valid. And there is a status LED, which indicates if there is an error or problem with the camera. Then you can take it apart by unscrewing 2 small screws on the back side and the ring with the holes on the front side. And that's all there is inside. There are 2 electronic boards and the image sensor board, which you can replace. So this you can easily do at home. This is the software that we have developed. It has all the necessary settings like exposure time, gain configuration, some image processing like dark subtraction, flat subtraction, and you can select different overlays. And there is also a region of interest function, which you can reduce the size of the file. The tool supports ADV and SER formats and also FITS files and integrates with the telescope and Occult Watcher. You can see on the right side, I have imported a couple of events from Occult Watcher. I will show you, if you have time after the slides, I will show you in a demonstration how this works. The camera now has a website. This is www.dvticam.com with images and description of the product. Yes, and we plan to add content on this page over time. add more information. I can quickly show you the web page. For example, there is a fact sheet on the main page, which contains some additional information about the two different versions of the camera, which you can see here. Yep. Also other sections like a gallery, not much content on it right now. And the idea is also that we put the tools, software, firmware updates here and to download. Okay. So now, how can you buy the camera? Luckily, before the chip shortage last year, we decided to build 25 cameras. At that time, there were only 14 image sensors available. So we have 14 of those 25 with the IMX174 sensor. And we had ordered IMX430 image sensors. I do have 2 samples for testing, but the rest of the sensors should arrive in early October, hopefully. It's impossible to create more cameras right now because many microchips in the camera are unavailable until they predict that they will be available until late next year. It is possible to get these components, but the prices are incredibly high. For example, a chip that normally costs $60 is now several $100, and we don't want to make the camera so expensive that we have to buy those prices. And it's also like second sources. You don't know who touched the components. They are very sensitive. And if we buy from brokers, then maybe the camera will fail after a while. So we decided to wait until the components are regularly available again. Here are the prices. These are the prices based on the components that we bought last year when the prices were still low. So we decided to sell the IMX174 model at 950 Swiss francs, excluding value-added tax. And we have set up a company here in Switzerland. And because it's a small new company, it is excluded from value-added tax. You can have sales up to 100,000 Swiss francs and are excluded from value-added tax. Unfortunately, if we deliver the camera into other countries, then we have to collect value-added tax for those other countries. For example, if we sell a camera to Germany, we have to add 19% at the moment. The IMX430 model, they will be a little bit more expensive. And we have also planned to have a sensor upgrade kit if you want to replace the sensor in the future. The next batch of the cameras, right now, the regular prices of the components, which are not available, but you can still see them from distributors, are about 15 to 20% higher than when we built this first batch. So I think the next batch will be more expensive because of that, but we will see. Maybe it will change and the components will be very cheap again, but we just don't know, just can't predict what happens. So for the ordering process, we have planned to start a sale of those cameras that we have next week. And if you order a camera, you should get the IMX174 version in October, maybe late October, and the IMX430 if we receive the components or the image sensors in November. And if there is more demand, we will start building more cameras afterwards. It depends on how many, if we can sell all the cameras and have still people who want to get the camera. The start of the sale and also additional information will be provided on this mailing list that we have created. There is a QR code on this slide. if you have not yet subscribed and are interested in the camera, you can photograph this QR code or open this web page and subscribe to the mailing list. I have a time plan here. We are currently in the final steps of setting up the company and bank account. And then we will, this will hopefully be finished next week. Then we will collect the orders. Then there is another round of certification. This should be the final one, packaging, and then the deliveries. So, and here is a short information on what we plan to develop further. In the short term, the finalization of the IMX 430 integration, this new sensor. We have a working firmware, but not all features are implemented in the software yet. Then we are also working on ADV compression so that the files from the control software are smaller. That is working, but we need to test it a little bit more. Also, we have some performance improvement that the software can run on less powerful full computers by distributing the workload and the processing on multiple threads, on multiple processor cores on the laptops, because nowadays most laptops have more than one core in the CPU, and we can use this. In the midterm, we have also samples of other image sensors, which should be even more powerful. And we have ordered boards from a board PCB manufacturer, and they should arrive in maybe late October or November for some tests to start. We also plan to support faster frame rates, improve the region of interest feature that we already have. Right now, this is calculated on the computer, but we plan to move this into the camera firmware so that that amount of data transferred over the USB cable is less. Then it will be less affected if other things run on your computer. For example, if you have Occult Watcher running and it needs to synchronize, then it will consume computation power. Maybe this is a general advice if you do a recording, that you try to shut down as many other processes as possible so that the full computing power and disk power is available for the recording software, independent of whether it is this PVTI cam or any other software, because this we record raw data and it really needs all the power that it can get from the computer. We have some other features planned, like automatic dark frame selection and a synchronous mode, so that we can synchronize the exposure with 1 PPS. What we do right now is to have a free running exposure, and we just put the start and end timestamps in the image, but we could also do it the other way around. The image processors support a mode where they receive a trigger signal and then start an exposure based on that trigger signal instead of triggering themselves. Long term, there is a plan to check if we should support Linux and macOS. There is also some software already available on those platforms, but it cannot use the special features from our camera. And maybe if there is enough interest, we could do a cooled camera. Especially with the more expensive sensors, I think this makes sense, like this scientific G-Sense sensor. This would certainly be something to consider. In the past few weeks, we did some first testings with the new IMX 430 sensor. This was the first test that I did. And about a week ago, Stefan and I were in the observatory and did some more tests, and I can show you some images. Here, for example, this is on the left side, you can see the FITS file from the IMX 174 at 24 dB gain and with a 1 second exposure time. And this is a star field in the constellation Pegasus. And a few seconds later, or a few minutes later, we recorded this exactly same region of stars with the newer IMX 430 sensor. And it seems really that this sensor is a bit more sensitive. It looks very promising. We have here some stars in this 1 second exposure, which we could not see or barely see on this IMX 174 image. Yes. Okay. But it certainly needs some more testing. We cannot quantify at this point in time how much better it is. And it seems from looking at the images that it can detect more stars or is more sensitive. Okay. As I mentioned, we have 2 boards currently being manufactured for more sensors that we want to test. Yes. Okay. These are the slides. I have also prepared a short demo of the tool. Maybe we can do this short demo first and then switch to the questions.
Okay, thank you. Interesting how this project advances. So it seems to be like it's ready to buy these things. I would have first a question for the quantum efficiency curve. So we know that the 174 chip has a relatively poor sensitivity, let me say longer than 850, 900 nanometers. Whereas on the other side, there are now chips available which have a quantum efficiency for 1000 nanometers for 25 to 30%, which is a lot. So how is the IMX 430 positioned in this field?
I have a screenshot of the data sheets. Let me check where we can compare the 2 sensitivity curves. It's directly from the data sheets of the 2 sensors. Unfortunately, it's a relative curve with respect to the maximum quantum efficiency of the sensors, which is given as 1. But actually, that's about 78, 79% for both sensors. So 1 is about 80% quantum efficiency. And you can see on the bottom curve that the IMX 430 is considerably more sensitive above 800 or in this higher wavelength area. For example, here at 800, we are close to 0.6 in this relative scale, whereas the IMX 174 is around 0.4. So that's about 50% more sensitive in this higher frequency ranges. Yes?
Because I think this is for occultation work very important. So if you have it in your data sheets, these curves, which gives the user some idea how sensitive it is, because otherwise it's both are, I think, global shutter chips.
Both are global shutter, yes.
Yes. Okay.
The pixels of the IMX 430 are a little bit smaller. They are 4.5 micrometers. Compared to 5.86 micrometers for the IMX 174. And the area that you can see, the area of the sky is a little bit smaller. If I have closed the FITS files, but there we can see that we have a 20 or 30% smaller region of the sky that we can see.
Okay, are there more questions here? Yeah.
Hello. First, congratulations for your amazing work. This is amazing to have such a product with all of those new features integrated, GPS and good sensors, because currently the only available product with GPS is the QHY with the IMX174 sensor, which is not the latest generation, of course, of the Sony sensors. My question is, have you considered also another version of those sensors, like the 432? Do you know that sensor?
Yes, we have it here, and we have tested it, and it's very similar to the 430.
Yeah, it is the same technology.
It has a much bigger field of view, and the problem is that it uses a lot more energy and gets hotter. And then you have don't have cooling in this first version of the camera. So what happens is that the dark current is much higher. You have much more dark current because the sensor gets to 60 or 70 degrees Celsius. I think it will work if it's very cold outside, because the heat can dissipate over the enclosure of the camera. And if it's below 0 degree, it works. But I think it's not practical for if you want to record occultations in summertime or when it's hot outside, because the sensor gets too hot. But the sensitivity is the same. It's the same pixel technology. Also, the IMX428 we have tested is the same pixel technology.
Yeah, what I'm seeing is that depending on the size of the pixel, the current noise increases. For example, if you have a pixel with the double of the length, you may have 4 times the sensitivity, but also 4 times the dark noise as well. The reason is that the 432 have a pixel size of 9 microns. And I think, I'm not sure, I'm not an expert, but that could be the reason why they have such a high dark noise, because also the sensitivity is very big. My point is, since the last CMOS sensor appeared in the market, there are not many alternatives for long focal instrument to match a good resolution with such tiny pixels. And there is almost no alternative, only the 432 version, which provides a big pixel size, and you don't have to bin it by software. It is, actually, those 9 microns are the 4.5 pixel already binned by hardware.
Exactly, yes, it's the same pixel, but they bin it 2 by 2. And there is also a sensor called the IMX433, which we have also tested. And this is identical to the IMX432, but it also has integrated binning to 9 micrometer pixels. That's the same. So you could also use this IMX433. If you have a special need, of course, we can do a special image sensor board for this specific use case. Yes.
Actually, the WattTech uses a sensor very similar to that. I don't remember which one is right now. Okay.
Thank you.
Thank you.
Well, thank you. Are there more questions?
Andreas, you have a few comments on the chat. Maybe you can open the chat on your own computer and answer it.
Yes, I will try. Sensitivity conversion. Quicker than USB interfaces. Yes, we are also looking into this. There are newer versions of USB and also Thunderbolt. Problem is that the controller chips are not available. There are some Thunderbolt to PCIe conversion chips, but for those, the technical information is not available. So right now, it's not easily possible to have a faster transfer. But what we try to do is to reduce the amount of data that we transfer by compressing it or by providing region of interest capabilities in the camera. But next version probably should have a faster interface, like Thunderbolt 3 or so, that we can transfer more data. And long-term plans, what does long-term plans mean? It depends on our time and yes, on also how much interest there is in the camera. And yeah, I think it means, yes, 1 or 2 years we will start working on this.
Well, something more? No. Huh? Okay.
In fact, there is a question by Andreas to Gunther. What's the weight of the telescope in the new box? Is it less than 100 kilos?
For the last talk.
You can answer. The weight of the biggest box is 30 kilogram, and the other ones are less than 20. So if you add this, approximately 55 kilograms in total.
Okay.
Okay, the next talk was supposed. The next talk was supposed to be given by Wojciech Brzezinski, but he will not give the talk. Instead, we have a few minutes for Roman Kostenko. He will show us what is the title?
Just a short story of the eclipse success or other failure from the last 2 years.
Okay.
And do I need the mic?
Sure.
Oh, yeah. Thank you, Wojciech, for letting me intervene.
Right. Like this is good. Oh, can you do it full screen or not really? Oh. Still a bit of charts.
In Zoom, we are looking at this.
Yeah. Okay. Okay. I mean, should be fine. Oh well. So it was an interesting period. Should I skip over the part that where our two past? Yeah. It's like that our two past ESOPs were online or hybrid or not attended. You all know that. Well, and another disclaimer, I do eclipse trips sometimes more as a photographer and a hobby than a research. So you can treat it as well as just tourism. However, I mean, the maps are from Xavier Jubier website. You're probably familiar with it. And here I begin. I had quite successful 2019, being to the total in Argentina and annular in Abu Dhabi. And that looked all good. So I made some plans for the next year, 2020. And little I knew what's about to come in spring. There was then annular, as you can see, the pass. Sorry, it's supposed to be a little bit bigger map. The pass of the annular was basically going through the Middle East, Oman. Well, Oman was the goal number one. At the moment, I lived in Poland, but well, most of Europe didn't have any of those in partial phases. So kind of half year in advance, I booked trip for Oman through Abu Dhabi. It seemed to be very easy and obvious and good weather in summer. Well, then March, the whole world went into lockdown. I realized it's not possible to enter Oman. It's not possible to enter Abu Dhabi. But still, I mean, within the European Union, there was some flexibility. And I tried to use a few low-cost flights to make a vacation out of it and see a partial. I booked Cyprus. Cyprus got canceled within a few weeks because the rules were changing every few weeks. You know, the entry gets restricted. And the vaccines were not available yet, just to say. Or the airline cancels your website. So I rebooked Cyprus into Athens, which got subsequently canceled. then I thought, like, I mean, I do have the voucher. Let me do at least Bulgaria. I mean, it's still a country, and then it got cancelled. So out of the 4 or 5 potential goals, well, I couldn't go anywhere. And I thought, well, at the moment, as I mentioned, I lived in Poland. As you may see, it's just outside of the partial eclipse zone. So I would have 0, 0 of nothing. That was frustrating. I used my citizen right to come back to my own country, which is Ukraine. That was still not without incidents, like the border was troublesome and they required me insurance or something, but well, I managed to see a partial back at home. That required quite a lot of plannings, refunds, and things like that. Well, what did I learn from it? There was this total long awaited, especially for those who have been to South America in the 19, they just said like, automatically it will come next year. So did I think? My goal was Argentina. I don't know, some lucky people managed to get in, but basically the, how to say, the international website for air travel was saying no entry for anyone. So there was a plan B, Chile. Chile was, I think, was closed for most people until like a couple of weeks before the eclipse. Then they impose very strict restrictions, like you have to quarantine or test double or triple, and you are only allowed to move within those provinces within that period of time. To my bad luck, I was finding myself in Turkey back then, and the only viable flight was with the 2 layovers in the EU, which was also restrictive. So I stayed at home and didn't go anywhere. However, my wife got the eclipse bug and she went without me. She had the French citizenship, so it helped her to go through Europe. Well, so she appeared here in Santiago de Chile. And that was not all because it was so-called red zone. Means you cannot stay more than 12 or 24 hours in the province, then you have to leave. Otherwise, you have to quarantine for the next 2 weeks or 10 days, I forgot. As well as the locals of Santiago, they were not allowed to leave the metropolitan area. And the eclipse was just a tiny bit, but it's still a 700 kilometers or 500 kilometers south. Well, so basically foreigners were allowed to transit through Santiago while locals were locked in at home with 80% partial eclipse. She managed with a Polish friend of mine to drive to the south, and they had to get there by midnight. Otherwise, the police was about to lock them in. And again, like every province has a different rule in Chile. It was an insane trip. Maybe I'm lucky I didn't go there. It was stressful. They couldn't sleep, but they had to lie to the police that they're just stupid tourists got lost trying to get into the eclipse pass. Oh, well, so no matter how hard you try, all of this western coast was extremely clouded. Well, it was a miss. So I still wanted to see something next year. Again, an annular. Well, it was north of Canada, a bit of Ontario, a bit of Quebec. There were a few roads, not an easy one, but for me, exciting as a travel destination. However, we all got used to COVID back then, so Canada was closed. Moreover, for the people who need a visa, I mean, it was basically closed. Again, and between the provinces, there was restrictions. Like, long story short, Canada canceled. I had a nice plan to Iceland, this time with a flexible tariff. Canceled because Iceland, it was allowing the entry, but you have to quarantine some days and you couldn't even leave you couldn't get to the capital. You had to stay near the airport. It was way too complicated, I thought, and the weather wasn't great. I just stayed in France back then. Well, it was a nice time. So I guess like after a year of this mess, I was a little bit getting on the nerves that you cannot go anywhere and all your plans, especially if they're related to world travel, were failing. Finally, 2 years into this story, it was my first trip, which was successful. Yeah, I accept critics for traveling to a partial eclipse half around the world. However, I'm happy I revisited Argentina. There were only a few people from outside of these countries who went there. Yorkshire, I think, was not that far away, and a few others. Well, at least that was a good one, and the restrictions were all gone by that time. It was April this year. Weather could be an issue as the south is famous to be like clouded. April was autumn, beginning of autumn there. My initial plan was San Carlos de Bariloche, and then I thought, okay, keep the flexibility always with you. That's what I learned from this period. I had my car ready to drive south or north, depends on what the weather was. Well, it decided to be that the south was practically all clouded, and the small city of Zapala in the so-called Argentinian Wild West was clear, like the nearest location to the south you can get from. And well, those who were on the north of it, like including the people who stayed in Santiago airport, they all had their luck. For me, it was also a discovery of a new region, the very much uninhabited and beautiful nature. The scenery went like this. Well, it's only a big middle of autumn back there, but it snowed in the Andes. Without knowing that, I crossed the main chain of Andes because they're not that high in this part of the country with about 1,600 meters altitude. Well, there was no snow down there, but it changed to snow up. The eclipse was happening at sunset in the whole continent, so I tried to get as much horizon as possible. In fact, in this panorama, the eclipse was touching a negative horizon of like -0.5 degree. By luck, I had this Chilean volcano across the border. However, the sun was not hitting it. It was about 4 degrees, let me think, south from it. Well, it was a ground track in the middle of the mountains. I couldn't relocate, but still I grabbed some nice pictures, and the partial eclipse of 40% or so went down smoothly with a sunset like that. Breaking into 2 parts, then it was rather spectacular one, catching a green flash because it was a negative horizon. What can I say afterwards? Keep trying, I think, and good luck. Buena suerte. We all know, so as Conrad said, the Australia eclipse is coming. Good for you if you have the direct flight, less good if you have layovers in other countries. We just keep our finger crossed that rules don't change. That's the tough life of the eclipse chase. If any questions, I'm ready. Awesome.
Thank you. Are there questions? The internet? No, nothing. Okay. Thank you. We can go to the next talk by Bruno Morgado by Zoom. He will talk about a package for data analysis called SORA, Stellar Occultation Reduction and Analysis. That's what we all need. So. Okay.
Hi, everyone. Everyone is listening to me? Yes? Okay, so I will share my screen here.
Wait a second, Bruno. I need to fight again the computer again. It's the same problem. Okay, bro. We are ready. Share your screen.
Okay, so I'm sharing my screen now. Can you see it?
Yes.
You are also seeing my mouse, right?
Right, yes.
Okay. So, hi, everyone. I'm very happy to give this talk here today. It's about the Python package that we have been developing here in Brazil. And so let me start by talking a little bit about our teams, the developers. So the main developer is Altair Ramos Gomes Jr. and also myself, Bruno Morgado. We are both professors here in Brazil. We also have the collaboration of Rodrigo Bufflet and Gustavo Rossi. Both of them are postdocs. We have Flavia Romel working as a PhD student in Observatório Nacional in Brazil as well, and also Martin Banda. So this is our main team and the main developers of Sora. And we are all part of the LuxStar collaboration. So as you may know, LuxStar is a very large collaboration that we are part of. The lead of this collaboration is Bruno Sicardi, and also the lead of the Paris team. We also have the Rio group here in Brazil, and our leader is Roberto Vieira Martins, and the Granada group in Spain with José Luis Ortiz as a leader. Within the LuxStar collaboration, we have been organizing and obtaining data from many places on Earth. So here's a map where every red dot here is a place where an observation was done in collaboration with us. And of course, thanks to many of you that help us in the pursuing of these occultations. And also we had the stellar occultation observed by Keops Space Telescope. Altair will talk a little more about this later. So this was a very interesting result as well. Okay, so the motivation of our package is mostly 3 points. The first one is Gaia. Gaia get positions of many stars with high accuracy. So now we know with very good precision the position of the stars. We also have work with to improve the orbits of TNO, centaurs, and the objects. And the idea is to be able to better predict the stellar occultations. So now we know the position of the stars. We also have good positions of the objects. We are doing astrometry runs here in Brazil and also in Spain, Granada, with the Granada group. And of course, we have still many things to do in the future. The LSST prospect is very impressive. So the LSST is the Legacy Survey of Space and Time, and it will be observed in the Verazzi Rubin Observatory. And for the solar system itself, this survey will probably discover a lot of small bodies in our solar system. And of course, this will also make the number of stellar occultations increase a lot. So in the end of the day, we are now in this big data era. We have a lot of events. This is only the LuxStar events for TNO, centaurs, and the Trojans. So we are increasing a lot the number of events per year. And not only we have more events, we have also more chords for each event. And yeah, so at the end of the day, we need new tools to be able to work with this many data. So that's the main goal behind Sora. Sora, at the end of the day, is a Python library. So you need to know a little bit of Python to work with that. And as a Python library, this package has various functionalities and tools that any user can use to reduce and analyze its data, okay? So our idea, or what we aim to do, is to create some modern, faster, and efficient tool to be able to deal with this large amount of data. And of course, we can also access to online databases such as the Gaia, the GPL Horizons, the GPL Small Body Database, VZA, and many others. So the idea is the user don't have to go in these web pages, get the numbers, and put in the software. The software will do it by itself. And also, you can control the automation. So if you want to choose any parameter by yourself, you can do this. You can also let the software choose the better parameters for you. And for that, most of the cases, they will go to the online databases or using some predetermined values. And you can have this control. You can also choose to leave it in a more automatic way, or you can really use the parameters you think is best for your science. And this library is separated into modules. That's good for us because at the end of the day, we can separate each thing in a Python class. And with that, it's easier to have control and really see what's happening behind. So these 6 balls, spheres here, is the main modules of Sora. I will talk each one by one in the next slides. So with the body module, the main idea is to control the body parameters, the occulting body parameters. So you can query object parameter from the GPL small body database. You can read and compute the ephemeris. You can also query to GPL horizons. You can read and compute from BSP files of your choice. And also you can compute from a text file, right, an ASCII file. For the star, you can query the star parameter for many catalogs. You can propagate the stellar position to the date of the occultation. That's very important for us. And also considering everything, considering the proper motion, parallax, and everything. You can also read and compute the stellar diameter. For that, you can read from Gaia DR2, or also compute based in the models of Kervella and collaborators, 2004, or Van Belli, 1999. So for that, you can choose also which diameter you want to use. And of course, if you know how to program, you can also leave it open and try to fit this value, the stellar diameter. Okay, for the observer, this is mainly straightforward. The idea is you can query observer location from MPC. This is quite easy. And of course, you can put by hand the latitude, longitude, and height of the observer, the position of this observer in Earth. And you can also add an ephemeris. So you can add a spacecraft as an observer, and that's an important feature that Altair will talk a little more about. Okay. And of course, as a spacecraft, you can also add something like a station in the moon or something like that. Of course, right now, we don't have any telescopes there, but the idea is, by a software point of view, you can do this. Okay, so going to the predictions, and the idea of this model, of course, is to predict stellar occultations and organize all the information into data frames. And as you have all this information, we also can create the occultation maps and also put everything for one observer or for the geocenter. And of course, for spacecrafts as well. So you can see these are occultations that are interesting for you, for the objects that you want to, and you can do this kind of predictions. The light curve, now with the light curve and the occultation modules are our most complex models. The light curve here, one important thing that I have to say that we do not do the photometry for the moment. We are only computing the light curves from files because there is many softwares that do the photometry. We have Tangra, we have PyMovie, and many others. And the thing that we tried to do in this first phase was to go to the next level, to get these light curves and do the analysis behind it. So you can read the light curve from an ASCII file. You can detect in stellar occultations, see the signal to noise of this detection. You can normalize the light curve if you want to by a polynomial or by some numbers. You can also create the models of these light curves. And here the model considers the Fresnel scale, the stellar diameter, and also the instrumental response. And of course, by modeling and changing the values, you can obtain the immersion and immersion times and the 1 sigma error bar for each one of these observations, with each one of these light curves. And with everything, with all these other modules, we have the occultation module that will combine all this information and put everything in place. So with the occultation module, you can put everything in the tangent plane, in the sky plane, and get the projections of the chords in the sky. You can fit a circular or elliptical shape for the moment. I will talk a little more about that in a few slides. And of course, you can calculate the position of the object at the moment of the occultation. We can also calculate the geometrical albedo and some other informations. So the idea of this module is to compute everything and put everything in the sky plane based on the light curves, the observers, the body, and the star. And these four, in my opinion, is our major capabilities. So we can predict stellar occultations. This is very interesting for us to keep this software doing these predictions. You can do the light curve analysis. So after the photometry, you can get the instance of the disappearance and reappearance of the star. You can fit the 2D size and shape of the object. And as Sora is an open source code, you can also use some functions as a starting point for other analysis. One thing that I have used Sora for is to detect material around objects. For instance, I have worked with Chariclo some years ago, and I used Sora for do that, to get the parameters of the ring of Chariclo and this kind of thing. So even though the ring functionality is not completely done yet, you can use it as a first guess for some analysis. Okay. And one of our main goals and something that we are very interested about is to create something that is open source and also open development. As an open source, the idea is that all codes, everything is freely available at GitHub. If you want to try it, go there, download the package and start using it. You can also install it just by typing pip install Sora Astro. In our online documentations, there are many Jupyter notebooks with tips and hints and how to get started. And there you can see everything there. But the idea, anyone can see the code. Anyone can go there and discuss with us, oh, I think there's other ways to do different steps. And of course, we want to listen to the user. And of course, we want help, because there are many things and many interesting features that we still don't think about. And we welcome anyone that can contribute with new ideas, bug corrections, new applications, and of course, with the development of new tools itself. So if you want to join us, you can also send a message to me, to Altair, and we can start a discussion. And of course, we'll be most interested in participate and collaborate. So our help desk is also on Slack. We have a Slack channel where you can ask questions and participate in science discussions, suggest new functionalities and everything else. This is something very interesting because as a scientist, we have many times to choose between what new feature we should create next. And it will be great to have your opinion and your interest in saying, I don't know, maybe listen to you and say, okay, so this is the next feature we will do because we have a demand for it. You have a science that you want to work with that. Okay. I asked Altair to put the link of the Slack channel here in the chat. And you can also find this link in the About Us page in our documentation, okay? And of course, you can also ask me, Altair, and many of us, and we can send you the link. And so, Sora is fully documented in the Read the Docs, so you can find our documentation there. There you'll find how to install the package, how to use it. We also have a lot of Jupyter notebooks with examples and getting starting guides. So the idea is to help you start using Sora. But of course, we know as a Python package, you need a little of Python skills to be able to use it fully. And that was sort of your actual version of Sora is v0.2.1, but we have many things interested and we have many ideas to do next. So right now in production, we have 4 main features. This is something that's almost ready and should be public in the near future. First of all is to input Gaia DR3 and also other catalogs. You can choose the catalog you want to do your analysis. Of course, the physical meaning of this is something that the user may choose and may argue, but the idea as a software, you can choose the catalog you want to use. Also, we want to work with 3D shapes, and this is a main feature of us, because we want to be able to fit the chords with known 3D shapes. And for that, we also need to compute the rotational elements. So how to put this 3D shape in space for a specific time. And this is also something that we have developed. And of course, we also trying to improve our methods, and we have improved our fitting methods to be able to do multiprocessing. This is to increase the velocity and be more efficient. As I said before, our main idea is to have as efficient as possible, a toolkit that's as efficient as possible. And about the 3D model, the idea here is you can project these 3D shapes, the known 3D shapes of the objects in the tangent plane. Here, we are not obtaining the 3D shape itself. We are only getting the 3D shape and putting in the sky, the known 3D shape. And we can find the limb of this figure and fit the central position of this 3D shape and also the scale, okay? So there's still some things that we want to develop. For instance, it's quite easy, but it's not very efficient yet. You can want to fit the pole orientation. And this is hard because it will change the shape. The position and the scale don't change the limb, only a little bit. So it's easier to work with and put it in an efficient manner. But the pole orientation is not that easy, and we want to find new and interesting methods to do that in an efficient manner. And that was Sora v03. That's our next version, and will be available very soon. And just to talk a little bit more about what we still want to do, and there's a lot of things we want to do. One of them is fitting multiple occultations. So the idea is you have multiple occultations by some objects. Right now, we are starting to have multiple occultations by many objects. And the idea is to put everything together to get the better 3D shape of the object itself. We also want to do the analysis of atmospheres. This is something that is already done in the Luxstar collaboration. You have saw the Triton occultation, Pluto occultation, and many others, and Titan occultation. But for the moment, Sora does not work with atmospheres, and we want to include functions in Sora that will work with atmospheres. Also, we want to create something more stable for search for material. That's very interesting. As you saw in Bruno Ziccardi's talk yesterday, this is something very hot in the moment. We want to find material around the objects. So creating a feature that is as automated and as efficient as possible, this is something very interesting. And of course, we have to modify our methods also to better deal with secondary events. This can be used for double stars, satellites, material, rings, and everything else. The idea is to put everything together and be able to compute better the secondary events. And yes, Sora is a Python package, as I said. You need some Python abilities to work with that. But we are also preparing something else. And for that, we had funds from Heisen Simons Foundation. And we are developing an occultation interface where we use Sora to get the parameters and the features we want. So you can use this interface to compute, to predict stellar occultations, and also to do the analysis of these stellar occultations. So this is still being tested, so we're still developing this, but just to tell a little bit that this is something we had in mind and something that we want to work on in the future, okay? And that's it, everyone. Thanks for listening to me. So as I said, our documentation, here's the link. Also the GitHub, here's the link. And we also made a scientific publication in monthly notices. So please, you can go there and give it a look.
Okay, thank you, Bruno. This seems to be very interesting. I read the paper in the MNRS. And when I see this, part of it is what in a more, let me say, condensed way presented by the occult software you may be familiar with. So it seems to be this is a modular thing in Python, which could be one step forward in terms of flexibility and so on. So this is a great thing. So what are any comments here and questions? Is there any in the internet? They're all impressed, I think, by this, what this can do. It solves the whole occultation problems, I think, from prediction to more or less, you only need a publication generator that puts out every month a Nature paper. That's the only thing what is missing, I think.
Yeah, that's something that will be very interesting for us.
Okay, well, so then we, the observer, have to deliver the observations and this package can analyze it. This is a good thing because there are some part of this what you present is available anywhere, but this seems to be a project which unifies it all under in one systematic way.
Yeah, and the main idea is to have everything public, so anyone can use it, and of course anyone can verify and see the methods we are using, and also to really understand what is behind the code. So that's one of the main prospects of this project.
Okay, I would suggest that everybody who has some ideas and some computer skills, maybe not, I think you don't need too many computer skills, you should use it in Jota or everywhere. So to get, and then you may get also some more response, what are problems, how it can be improved. Well, if there's no more questions, then we have to thank you again, and we have to go to the lunch part.
Yeah, before the lunch, Andreas needs some more time because he wants to present some demonstration from the previous talk.
Also,
yeah. So, Andreas, are you there?
Yes, I'm here.
Okay.
There was some misunderstanding.
So, yeah, maybe we interrupt you. Okay, go on.
Okay. From the previous talk, what I just wanted to show you was the software tool to control the camera. Only 5 minutes or so, then I'll let you go to lunch. Let me check. Okay, the tool runs on a Windows machine, Windows 10 ideally. And I have now started the tool. It's called the DVTI Cam Control Tool. I have a button to connect to the camera. And when it's connected, it shows some information about the image sensor that it has recognized, serial number, firmware version, and it's connected via USB 3. Then I have a box to select the resolution. We support some binning modes with the software. And now I can start. I can either disconnect here or start streaming. And if I'm not streaming, I can also update the firmware of the camera by selecting a new firmware and then installing it. Now let's start streaming here. It's filming an equipment in the lab here, just anything. Now you can see a histogram here of the intensity. I can adjust. That doesn't affect the recording, it's just for the preview window, so that I can optimize to really see the occulted star here in the preview window. I can scale here and zoom in. Like, for example, if I want to see something bigger. I have overlaid a crosshair at the moment so that I can put the star in the center of the image if I want. I could also add a plate solving result here, then it will show the result of the last plate solving in the image. Okay, here at the bottom you can see the GPS timestamp. I have to scroll down the presentation. Here you can see the timestamp. It's synchronized to the GPS to several satellites here, some GPS and some GLONASS satellites, as we can see from the numbers here. And it has the correct time. Then here I have some tools to directly start the recording. For example, an ADV file. Now it's recording in ADV format, or a SER, the older format of FITS series. I can also take single snapshots, light or dark frames. For the dark frames, the tool can average a number of frames so that we can reduce the noise in the dark frame, or here a flat field as well. Okay. Then I can configure, of course, the gain of the sensor, the exposure time. This sensor has a high gain mode, which I can activate, which improves the gain even more. I can change the exposure time here. So here are some other controls. I can add a dark. I can subtract a dark life in the video stream. I select one here, but obviously it's not the correct one for this exposure time. It has to have the same exposure time, of course, and ideally the same temperature. You see, it gets a little bit corrected. Yes, and then there is the integration with Occult Watcher. So say I want to observe a couple of events, then I can open this this event window where I can see the events that I'm planning to observe. I can switch to Occult Watcher. And let's see what we have. For example, this evening, I can say forward event to DVTI cam control. Let me forward a couple of events here. These three, for example. And now you see that they appear here in the occultation events window with some basic data. And if I click, I can also remove them here if I don't need them. I can click on them to make the window bigger and have more information. And from this window, I can create the text file report for Europe, which is then filled out with the information from Occult Watcher, like the star, the expected delta magnitude, and so on. And it's also filled with my observer data, which I can enter in the tool, observing station. And if I create a report after recording, then it will also add the start and end time of the recording. What it cannot do, it cannot detect the event. So those 2 lines, if you have a positive, you have to fill yourself. But everything else will be filled, also the information on the camera, from the tool automatically. So it's very easy if you have an observation to create the report afterwards. You can open C2A, or you can also connect to a telescope, which I can't demonstrate right now because it's not connected to the telescope. But we support the ASCOM driver. Let's see what happens here. And you can then, it connects a simulation here. You can then slew the telescope or synchronize the telescope to the plate solving result that you have here, or slew to the event. That's some integration with the telescope. Yeah, and that's about it. These are the most important features of the tool. And with that, this finishes the talk, and I let you go to lunch.
Thank you, Andrea. You have a comment on the chat?
Can you plan recording time interval? Yes, that's possible. Sometimes we have an event late in the night and we don't want to stay up. So what we can do is click on this button here. And then you can say that you want to record automatically. For example, if I have this event here, and then we say delayed start, ADV, and we click on start. And it copies the center time from the event. If you click on this button, now this should match the time of the event, 18:06:51. You can define the duration on the left and the total duration of the recording. So it will start 30 seconds before this center time and run until 30 seconds after. Then you can click on start and it will start a countdown. One of the long-term goals is to have also a better feature here, which you can just run the program in the evening and it will record the first event, then slew the telescope to the next event, record the next event, and so on. All the pieces are in place. We have the telescope integration, we have the list of events, we have the plate solving to check if you are at the right position and fine-tune the position. So this is definitely something that we can do, but it will take a little bit programming to implement this feature. But that's something I think if we can just start the telescope in the evening and let it run during the night, and in the morning we can check if you have positives, maybe this would be a funny feature for the future. Let me check if there are other. Signal noise ratio. The signal noise ratio, yeah, there is an experimental photometry tool here where you can go over, where you can place a cursor somewhere, and then it should report the signal to noise, but that's not finished yet. But the goal is that you can detect the signal to noise ratio in the image in the future, but it's not working at the moment. Okay, yes, that would definitely be useful, but not yet finished.
Okay, thank you. Any question in the room here?
Well, Andreas, I have a question. If you record a fit sequence, can you add information in this file, like the observer, the telescope, the object, and so on, or?
Yes.
As keywords, yeah?
Yeah, you can configure the keywords here. For example, if you say here, you can configure different observers, different stations, and then if you do a recording,
Oh, yeah. I see it, yeah.
Like here, then you have the information. Let me check here. I think it's here. It will put.
Oh yes. Oh yes.
It will copy the information from the configuration into the fits file.
Mm.
Of course, if you wish that we add more information, this is also possible to extend the tool in the future. Right now, it has just a couple of things that it adds here. Yes?
Okay. Okay, thank you. Because this is sometimes very important that you can write some comments in the fits file and keywords. Okay, thanks.
You're welcome.
Okay, I think we can close the session here and go for lunch. For the Zoom participants, I will close the meeting room, and I will open again at 5 minutes before 2:30. Yeah, we will start at 2:30 again. So thank you.